Section 2.1.4 Development and Operations as One System. Let me start with a scene. It's 2 in the morning. Production is down. Customers are complaining. Dashboards are flashing red. Operations is trying to stabilize the system. Developers are being called in. And the first question that arises isn't, how do we fix this? It's, who caused this? That moment explains why traditional software organizations struggle. Because when teams are separated, the system reacts slowly. Information moves through people instead of flowing through the system. For years, development and operations were treated as separate worlds. Developers wrote code and handed it off. Operations handled what happened next. When things broke, the wall between them became painfully visible. Outages dragged on, delivery slowed, burnout followed. DevOps begins by removing that wall, not by merging job titles, not by eliminating specializations, but by treating development and operations as one system, one continuous learning loop. This isn't a slogan. It's the foundation of everything that follows. When development and operations act as one system, responsibility changes. It's no longer your code, my outage. It becomes our service, our responsibility. Reliability isn't owned by operations alone. Speed isn't owned by development alone. Outcomes are shared. If uptime drops or recovery takes too long, it's not their problem. It's everyone's problem. And this changes behavior. Developers start thinking about how their code behaves in production. Operations teams stop acting as gatekeepers and start acting as enablers. Automation, monitoring, and deployment are designed together, not thrown over a wall. The entire flow, from idea to code to deployment to observation to learning, becomes a single cycle. Not a handoff, not a relay race, a loop. And loops are powerful because every incident feeds learning back into the next release. Let's clear up a few misunderstandings. Unification does not mean operations disappears. It doesn't mean developers suddenly do everything. Specialization remains. What changes is accountability. People keep their expertise, but they stop optimizing only their corner of the system. And this isn't just for massive cloud-native companies. Small teams benefit just as much. Even traditional organizations can start by unifying ownership around services instead of departments. And no, this is not the same as Agile. Agile improves how software is built. DevOps completes the picture by keeping operations inside the loop. Without that, speed simply creates instability. You can deliver features faster and faster, but if nobody owns what happens after release, problems just pile up. So what actually happens when teams work as one system? Recovery gets faster. Deployments become safer. Failures become smaller. The exact numbers matter less than the pattern. Unified teams behave better under stress. This is where AI enters the story. AI doesn't create unity. It amplifies whatever structure already exists. In a unified team, AI might detect an unusual spike in memory usage, connect it with a code change deployed 15 minutes ago, and alert both developers and operations at the same time, pointing them to the same probable cause. In siloed teams, the same AI just sends more alerts, faster, louder, to different people. Confusion accelerates. AI doesn't hide problems. It exposes them. That's why structure matters more than intelligence. AI accelerates whatever system you already have. Unity makes AI powerful. Silos make it dangerous. This is exactly what the 3 ways of DevOps describe, not as theory, but as lived behavior. The first way is flow. Think of it like removing traffic lights between development and operations. Work moves smoothly without stopping at handoffs. The second way is feedback. Think of a shared GPS. Everyone sees the same route, the same obstacles, and the same position in real time. The third way is experimentation. Think of a flight simulator. Teams can safely test ideas and learn before touching the real system. Without unity, these remain ideas. With unity, they become daily practice. Flow, feedback, and experimentation only work when teams see the system as a whole. Now imagine that same 2 in the morning incident again. But this time, developers and operations are already looking at the same dashboards. They see the same metrics. They trace the issue together. Code and infrastructure are adjusted side by side. There's no waiting for tickets, no handoffs, and no debate about ownership. What used to be hours of chaos turns into a short learning loop. It means the same team that writes the code also feels the consequences in production and learns directly from them. That's what one system looks like in reality. Let's draw a clear contrast. In siloed systems, development optimizes for speed while operations optimizes for stability. Metrics conflict. Outages create tension. Burnout rises. In unified systems, teams share responsibility for uptime and change failure. The same metrics apply to everyone. Learning happens together. Automation becomes safer instead of risky. This is where platform engineering fits. If one system is the philosophy, platform engineering is the workshop where it becomes real. It turns good intentions into repeatable, supported ways of working. Instead of every team reinventing tools, organizations build internal platforms, paved roads designed with reliability in mind. Developers don't wait for approvals. Operations doesn't block progress. One system, two perspectives, shared tools, shared metrics, shared outcomes. But the rule still holds. Without the right culture, platform teams simply become another silo, just with better tools. Unity must come first. Why does all of this matter so much? Because most major failures don't start with bad code. They start with poor communication. Take the Night Capital incident. Hundreds of millions lost, not because the technology didn't exist, but because teams weren't aligned. A unified feedback loop could have caught the issue before it exploded. The failure wasn't technical complexity. It was a broken feedback loop. Unity reduces surprises. It builds resilience before emergencies happen. So how do teams actually get there? By working in cross-functional squads, by keeping infrastructure as code alongside application code, by sharing dashboards, metrics, and alerts, by running blameless reviews, by designing rollback and recovery together, by using platforms to enable, not control. One warning is worth repeating. Creating a separate DevOps team usually recreates the same old silo. Unity has to live inside product teams. Otherwise, you just move the wall instead of removing it. Real organizations prove this works. Netflix operates with full-cycle ownership. Amazon follows the same principle. Teams that unify shorten release cycles and improve reliability. Teams that stay siloed struggle, especially once AI enters the picture. That's why interviewers care about this topic. If someone asks how treating development and operations as one system improves recovery time, the answer is simple. Shared signals, shared ownership, faster coordination. If they ask how to design a unified pipeline, focus on shared metrics, shared visibility, and fast feedback, not just tools. And if they ask what one system really means, say this: one flow, one responsibility, many specialties, working together. Let's end with 3 ideas worth remembering. Development and operations are not separate teams. They are one learning system. Unity turns speed into safety. And platform engineering is Unity made practical. Everything else is just tooling around the edges. In the next section, we'll explore feedback loops, the mechanics that keep the system healthy and improving. End of section 2.1.4.